All right, so now we're going to go over the Unit 10 Day 6 warm-up. If you have not completed the warm-up yet, please make sure you pause the video and then press play once you have finished it. All right, so number one from this warm-up is a review from the previous unit. We know this because they start talking about Jose investing his money in a fund that pays 3.6% compounded yearly. As soon as I see that 3.6%, I should immediately start thinking about the fact that this is an exponential problem. Okay, so since it's exponential, we need to think, is it exponential growth or is it exponential decay? Well, to figure that out, we have to think about the problem. So we're talking about Jose investing money and that it's in a fund that pays him. So if it's going to pay him money, that means it's exponential growth, which means we're going to use the formula F equals I, 1 plus R to the T power. Remember that you're expected to list out the variables and what they represent. So in this case, if he's investing money into an account that pays 3.6% interest, 3.6% is our rate. Now remember, we need to get rid of the percent sign, so we have to move the decimal over twice, which makes my rate 0.036. Then I read on and it says he invested $750. So since that's how much he had at the start, I, which stands for initial, is the start, so my I is 750. And it asks how much will he have after 4 years, so my time is 4. So when I plug this in, we have F equals, instead of I at 750, 1 plus 0.036 to the 4th power. My first step is to combine what's in the parentheses, so we would have 750, 1.036 to the 4th power, and then I would just go ahead and type this in my calculator. And you would get 863.97 if you round appropriately. And then we would need to go ahead and write our sentence. So I would say, after 4 years, Jose will have, and I put the dollar sign because we're talking about money since he invested money, so it's $863.97. All right, then we need to go ahead and fill in our perfect squares since we're using those every day, which would be 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225, 256, 289, 324, 361, and then 400. All right, so today we really are going to be building off of what we have done, what we did the other day. Okay, so we started out multiplying the other day. Now we're going to go ahead and take that multiplying to the next level. And instead of just multiplying with radicals, we're actually going to be using the distributive property, which involves multiplying. So the multiplying is just one part of what we're doing today. So you see that happening to build off of our previous stuff is going to continue on. Okay, now just a reminder of what distributive property is. I'd like everyone to write this down in the corner. So we've done distributing before where we had something like 3 parentheses 2x minus 10. So when we did problems like this, we had to distribute. So we had to do 3 times 2x, which is 6x. Now normally we didn't write this 3 times 2x down. But today it's going to be really important that you show that step because we're distributing with radicals, which makes it more difficult to do. So we need to show our work by showing what we're multiplying together. Now remember, when you do the next step, you're not just doing 3 times 10. You're doing 3 times negative 10 because the minus sign makes it negative. So 3 times negative 10 would be negative 30. And we could stop there. Now that basic concept is what we're going to be using today, but now we're going to be doing that with radicals, so it takes a little bit more work. So sometimes it will be necessary to use the distributive property, which I'm going to abbreviate prop, when simplifying certain problems involving multiplication of radicals. I will tell you that distributing is necessary whenever you need it when there is addition or subtraction in the parentheses. So anytime you see addition or subtraction in the parentheses, you're going to need to distribute. The same basic rules apply that we did before. So when I'm multiplying with radicals, if there are two outside numbers, I multiply them together. If there are two inside numbers, we'll multiply them together. But we're going to do this one step at a time. So when I look at number 1, the first thing I notice is that there's an addition sign here, which means I'm going to need to distribute. So the first thing I'm going to do is I'm going to multiply the 3 times the 4. And then I'm going to cover everything else up because that's all I have to focus on right now. Well, 3 times 4 is 12. Is there anything else for me to do here? No, because there's not any square roots. There's nothing to reduce, so I'm good at that point. So that first step was pretty easy. But now I'm not done distributing because I only multiplied the 3 times the 4, and I have to do 3 times the next one. Now remember, when you take that next one into consideration, that addition or subtraction sign will tell you what type of symbol you're multiplying by. So in this case, I'm doing 3 times positive 3 root 5. So this is where I need to focus. If I have two outside numbers, then they should get multiplied together. If I have two numbers inside the radical, they should get multiplied together. So I can ignore this altogether, and this is the only piece that I'm focusing on. And in this case, we have two outside numbers, a 3 and a 3. So we're going to multiply 3 by 3, just like we would have yesterday, and got 9. Okay? There's no other number in a radical, so I don't have to worry about multiplying the 5. I'm just going to bring square root of 5 down. At this point, I'm going to need to check and see, can I simplify this at all? Well, there is not, so I look at my perfect squares at the top. The only perfect square smaller than 5 that matters is the 4. 4 does not go into 5 evenly. So we can just leave it because there's no perfect square that goes into it. And my other number was a 12, and my 9 was positive, so it would be plus. So right now I have 12 plus 9 root 5. The last thing I have to ask myself is, can I combine these two together? Well, this one has a radical of 5, this one does not. So since they're not like radicals, that is my final answer. All right. So the next thing that we're going to do All right, sorry for that interruption. So the next thing we're going to do is looking at number 2. Again, I know I have to distribute because there's a subtraction sign in here. So the first thing I'm going to do is multiply the first thing, which is 9 radical 5, times 2 radical 3. And now I'm going to cover up the rest of this because it doesn't even matter right now. That's the only thing that I'm focusing on. And now this is just a problem like we did yesterday. So if I take this one step at a time, we're really just doing 2 problems that we did yesterday and then putting them together. So now we take our outside numbers, which in this case is the 9 and the 2, and we multiply them together. So 9 times 2 is 18. Then we're going to take the numbers that are inside, and since there's 2 numbers inside, we're going to multiply those 2 numbers together. So 5 times 3 would multiply together to give us 15. And then I need to check to see if I can simplify this. I need to go as far as I can with this problem simplifying-wise before I even worry about doing the next distributing step. So 15 is not a perfect square, and there's not a perfect square that goes into it evenly. So in the end, 18 square root of 15 is as far as I can go with this side. So now I'm going to ignore this side of the problem and work on the other side. So now I have to distribute the 9 root 5 to not just 2, but to a negative 2 since that minus sign is there. So we're going to do 9 square root of 5, and we're going to multiply that by negative 2 because of the minus sign. So I have to refer again to this. Are there any sets of outside numbers or inside numbers that we can multiply? Well, in this case, the 9's on the outside and the negative 2's on the outside. So I can go ahead and do 9 times negative 2, which is negative 18. There's only one radical, so that one radical will just get brought down to be the square root of 5. So now when I look at this, I have 18 square root of 15 minus 18 square root of 5. And I need to ask myself if I can put these together. Now remember, if I can combine them, they would have to have the same number in the radical. In this case, it's a 15 and a 5. They're not the same. So my final answer is 18 root 15 minus 18 root 5. All right, so I'd like you to take a minute and pause this video and try number 3 right now on your own. When you feel like you're starting to struggle, put your pencil down so that we know you're ready to start seeing how this goes. Okay, so now that everyone has tried this problem, at least attempted it in some way, let's go over it to see, sorry about that, that light will turn back up in a second. Let's go over this problem to see what you did right and to make some changes. So if you did things wrong, make sure you're fixing them as we go along. So when I first look at this, I know that it's distributing because there's a plus sign. So we're going to take 2 root 14 and we're going to multiply it by that first term, which is 3 root 2. And again, I'm not going to worry about any of the rest of this. I'm just going to focus on this piece. So now I know I can multiply my outside numbers together. So I'm going to multiply the 2 times the 3, which is 6. And then I'm going to multiply my inside numbers together. So the 14 and the 2. Well, 14 times 2 is 28, so this is square root of 28. Now, 28 is not a perfect square, but you do need to simplify it because there is a perfect square that goes into it evenly. So you should take a moment and try to find that largest perfect square that goes into 28. Well, 25 doesn't work. 16 doesn't work. 9 doesn't work, but 4 does. So 4 is the largest perfect square that goes into 28, and it goes into it 7 times. And I still have my 6 out front. So now I can go ahead and take the square root of 4, which is 2, and bring down my 6 and my 7, and 6 times 2 is going to be 12 square root of 7. Now I'm done with the first part of this, and I need to move on to the second piece. So for the second piece, we're going to go ahead and we're going to do 2 root 14 times positive 5 root 3. So 2 root 14 times 5 root 3. Again, I can completely ignore this side because it doesn't matter anymore. This is the only problem that I'm working on. So we're going to take our outside numbers and multiply them together. 2 times 5 is 10. Then we're going to take our inside numbers and multiply those together. So 14 times 3, which is the square root of 42. Now again, 42 is not a perfect square, but I still need to look and see if there's a perfect square that divides into it evenly. So I would try 36 first. Nope, that didn't work. Then I try 25. No, 25 didn't divide into 42 evenly. 16. No, 16 didn't work. Now 9. No, 9 doesn't work. And 4 didn't work either. So that cannot be simplified, so I can just go ahead and bring that down. 10 square root of 42. And since it was positive when I multiplied it together, there's going to be a plus sign in the middle. Then I should look and see, can I combine these? Do they have like radicals? Well, this one's a 7, this one's a 42, so they're not alike. So I can go ahead and circle that as my final answer. All right, so we're going to go to the back side with the next video.